Hi guys, so today we're going to be talking about properties of logarithms. So before we get started with our examples, I am going to combine example 1, 2, and 4, which is all of our properties of logarithms. Let's take a look at each of them, okay? So here we are going to start off with the product property of logarithms, okay? So here it says, and whereas the logarithm of a product is the sum of the logarithms of its factors. Okay, so basically what we have here is if I have log base b of m times n, I can split them up into log base b of m and log base b and n, and then I would add them, right? So here we see this log base 3 of the 4 times the 7. I can separate it into log base 3 of 4, and then change plus log base 3 of 7, okay? I'm going to explain why in a bit, okay? The quotient property, quotient meaning divide, so in this case then, if we're taking the logarithm of a quotient, we can separate them into subtraction. So it would be log base b of m minus log base b of n. Okay? And then the last one we have is our power property of logarithm. Okay? And so here, if it's log base b of m to the p power, what we can do is we can take this exponent, this power, and move it out to the front and do it as a multiplication of the logarithm. Okay? And so these all come basically from our exponent properties, right? So remember that exponent and logarithms are inverses of each other, and so that's why their properties are related here. Okay, so I have an example, right? So this is our product property, right? X squared times x to the third. What do we do with our exponents? Right, we add them. It's x to the 2 plus 3, and it becomes x to the 5th, right? So note here, when we're multiplying, right, we're adding our powers, and so that's why here, when we have our logarithm, note that this is multiplication, and so that's why we are adding them, okay? So the same thing goes with quotient, right? For a quotient property for our exponents, x to the 5th over x squared, note that it was the top one minus the bottom power, right? It becomes x to the 5 minus 2, which is x cubed. So same thing with logarithms. If we're taking the logarithm of a quotient, it's going to be logarithm of the top minus the logarithm of the bottom, right? And it's based off of this idea here. Okay? The power property is a little bit harder to see, but note here, when we have x to the third raised to the 4th power, we multiply here, right? So remember, the answer to my logarithm is my exponent, right? So this here is my exponent, right? And so since it's multiplying, that's why I'm multiplying my exponent, right? This is an exponent with my exponent, and that's where it comes from. Okay, so now let's apply these properties, right? So here I have log base 2 of 3 is approximately 1.5850. Okay, so here we're not going to be using really calculators in this lesson except for our word problems because I want you to learn kind of these properties of logs and how to use them, versus some of our calculators are quite powerful and it allows us to change the bases and all that other stuff. Okay, so no calculator allowed generally, so that way you're forced to kind of use these properties and understand how they work. Okay? Also, since some calculators, they actually don't let you change the base of the log. It's always just the common log, which we'll learn later is log base 10. Okay, so here we're going to use this number that we're given to approximate the value of log base 2 of 48 using my different properties. Okay? So what I'm going to do, I have to rewrite everything in terms of what I know of log base 2 of something and log base 2 of 3. Okay? So 48 is 16 times 3. So note that this log base 2 of 3 now. 16, I can rewrite it in terms of base of 2, right? So log base 2, 16 can be written as 2 to the 4th, right? 2 to the first is 2, 4, 8, 16, so 2 to the 4th is 16. Okay. And then here, according to the product property for logarithms, I can separate this into log base 2 of 2 to the 4th plus log base 2 of 3. Okay. Remember, solving a log is finding the exponent, right? So 2 to the what power gives me 2 to the 4th? Well, 2 to the 4th gives me 2 to the 4th. So I could rewrite this as 4. Okay. So note how this becomes this here, this 2 to the what power gives me 2 to the 4th? That's 4. Okay. And then the other part comes from this 3, right? 16 times 3 is that 48 here. Okay. And then note how, now I know what log base 2 to the 3 is, right? It's 1.5850. So 4 plus 1.5850. Okay. Should not need a calculator for that. So 4 plus 1.5850 is 5.5850. And there you go. Okay, now let's do our next one here. Log base 3 of 5 is approximately this, and log base 3 of 20 is approximately this. I want to know what log base 3 of 4 is. Okay. So here, 5 and 20, how does that relate to that 4? Well, I know that 20 divided by 5 is 4. Right? So I can rewrite this log base 3 of 4 as log base 3 of 20 divided by 5. Okay. Then this is my quotient property, so I can separate them. So log base 3 of 20 minus log base 3 of 5. Okay. And I know what that is from here, right? Log base 3 of 20 is 2.7268. Log base 3 of 5 is 1.4650. Okay, and then, right, 2.7268 minus 1.4650. If I can't do it while it's vertical, that's fine. You can while it's horizontal, you can rewrite it, right? So that way you can do it without the calculator. Okay, so this is 1.2618. And so log base 3 of 4 is approximately 1.2618. Okay. Last example before you try it on your own. Log base 4 of 6 equals 1.2925. Approximate the value of log base 4 of 36. Okay, so I'm going to rewrite this in terms of this. Okay, there's actually two ways you can write it. Right, you can rewrite it as this. Right, 6 times 6 is 36, or you can rewrite it as 6 squared. Okay. You'll get the same answer. The only difference is that this would be using the product property, so this would be using this property, and this would be using this property. But either way, you should get the same answer. Okay, so since we haven't used the the power property yet, let's use this one. Okay, so all I'm going to do is move the 2 out in front. So now it becomes 2 times log base 4 of 6. Okay, which I know is 1.2925. So all I have to do is 2 times 1.2925, and that gives me 2.585. There we go. Okay. Here, if we did it this way, right, it would be log base 4 of 6 plus log base 4 of 6, right? So it would just be 1.2925 plus 1.2925, which is the same as 2 times that. So either way, you would get the same answer, right? Because both of them are just two different ways to rewrite that log base 4 of 36. Okay, so why don't you try check your understanding, not check your progress, but check your understanding number 1, 2, and 3, and then come check your answer when you're done. Okay, so for 1, you should have gotten 2.6309. For 2, you should have gotten 2.4021. And for 3, you should have gotten 1.1403. If you got that right, you can move on to the next example. If not, here is your explanation. Okay? So 3 to the 18th, thinking of how I could rewrite this in terms of 3s, right, where it's the base, 2s and 7s. 18 is 9 times 2. So I can rewrite 9 as 3 squared. Okay. And then since it's the multiplying, I could separate them based off of the property of logs using the addition. Right? So log base 3 of 3 squared plus log base 3 of 2. Right? This moving out in front, log base 3 of 3 is just 1, or 3 to the what power gives me 3 squared, that's 2. And then log base 3 of 2, my approximation is here. Add them two together, 2.6309. Right? For number 2, log base 3 of 14, I can rewrite 14 in terms of 7 and 2 as 7 times 2. Right? So here, since this is the product property, it's going to be separated with addition. So log base 3 of 7 plus log base 3 of 2. This is 1.7712, right? And this is 0.6309. Add the two together, that gives me 2.402. Okay. And the last one here, I'm taking the log of a quotient. So using the quotient property, I can separate them using subtraction. So log base 3 of 7 minus log base 3 of 2. So that is 1.7712. This is 0.6309. Subtract them, and I get 1.1403. Okay, now, so that was example 1, 2, and 4. I went a little bit out of order, so that way you can see all of the properties together. Okay. Now, let's work on example 3. Okay. So the loudness L of a sound is measured in decibels and is given by this equation here. Capital L, the loudness, equals 10 times log base 10 of R, where R is the sound's relative intensity. Okay. So suppose one person talks with a relative intensity of 10 to the 6th, or 60 decibels. Would the sound of 10 people each talking at the same intensity be 10 times as loud, or 600 decibels? Here we're going to explain our reasoning. Okay? So here, what we're going to do is let L of 1 be the sound of one person talking. So L of 1 is one person talking. So this is 10 times log base 10 of 10 to the 6th, right, or 60. So 10 to the 6th. Right. So this here came from one person talking. Okay. So then we're going to let L sub 2 be 10 people talking. So 10 log base 10 of, and so now since this is one person's decibel, we're going to do 10 of them, so 10 times 10 to the 6th. Okay. So this is 10 people talking. Right. 10 people each talking at the same intensity. So 10 people, so that's why it's one person's intensity 10 times. Right? Okay. So then we want to know the increase of loudness. So we're going to do L sub 2 minus L sub 1. So L sub 2, 10 log base 10 of 10 times 10 to the 6th. Minus my L sub 1, 10 times log base 10 of 10 to the 6th. Okay. So then we're going to solve this. I could separate this 10 to the 10th, 10 to the 6th. With 10 log base 10 of 10 plus 10 Or just not, I'll just multiply, plus log base 10 of 10 to the 6 minus 10 log base 10 of 10 to the 6. Okay. Simplify this, distribute my 10, so this becomes 10 log base 10 to the 10th plus 10 log base 10 of 10 to the 6th minus 10 log base 10 to the 6th. Okay. So note how these two cancel each other, leaving me with 10 log base 10 of 10. Log base 10 of 10, 10 to the what power gives me 10? That's 10 to the first. So this is just 10 times 1, which is 10. Okay, so what this means is this is the loudness, right? This is how many decibels it is, right? So the sound of 10 people talking is only 10 decibels louder. Right? Louder. Right? Than the sound of one person talking. Or another way to think about it, if this is 10, right? 10 to the first times 10 to the 6th, this is 10 to the 7th, right? 10 to the 7th, 10 times 10 to the what power is 10 to the 7th? That's 7, so 10 times 7 is 70 decibels. Okay, 10 decibels louder. Okay, or it's 70 decibels total. Right. 10 people talking is only 70 decibels. And there you go. Okay, so why don't you try CYP3, and then once you're done, come check your answer. Okay, you should have gotten that if it was 100 people talking at the same time, it would be 20 more decibels, or 20 decibels louder compared to just one person talking. If you got that right, you can move on to our last example. If not, here's your explanation. Okay. So I set it up similarly to the one before. So L sub 1 is one person talking, right? 10 log base 10, and then this is the intensity, 10 to the 6th. Okay. Then 100 people, the thing that changes now is this intensity, right? It's the 100 people talking at that same intensity. So that's why it's 100 times 10 to the 6th. To figure out the difference, right, how much louder, it's going to be 100 people intensity minus 1 person intensity. So this is 100 person intensity minus the 1 person intensity. Okay. Because of this multiplication, I separated it with the product property. So 10 log base 10 of 100 plus 10 base log 10 of 10 to the 6th. Okay. These cancel out, right? They're the exact same. Leaving me with just 10 log base 10 of 100, also known as 10 squared. Okay? 10 to the what power gives me 10 squared? Well, 10 to the second power gives me 10 squared. Okay, so that's why it's 10, and then this here simplifies to 2. 10 times 2 is 20, so that's why it's 20 decibels louder, 20 more decibels. And there you go. Okay. Okay, so our last example is solving equations using our properties of logarithms. So what we're going to do is we're going to kind of condense our logarithms to be as small as possible, hopefully to a single logarithm. Okay. So here on the right, you can see that it's already a single logarithm. So here, though, it's several logarithms. Okay. So remember, in order to use these properties, all of the logarithms have to be the same. So that's a good thing to check, or else you can't simplify it using these properties. Okay. So here, it helps that all log base 5. Okay, so this 3 here I see out in front, I can change to be an exponent. Okay, so then this would be log base 5 of x cubed minus log base 5 to the 4, 5 of 4 equals log base 5 of 16. Okay, then here, because of this minus that I see, I'm going to use my quotient property. Right, so log base 5, oh wait, I don't know why I wrote it in red, I'm sorry. So log base 5, and it's going to be x cubed over 4. Okay, we're taking the logarithm of this whole thing equals log base 5 of 16. Okay, so because of that minus, I should be using the quotient property. Okay, and then now, right, we learned from the previous lesson, logs are the same here. Now it's condensed. Okay, so I have to condense it before I can do this. Now I can say that x cubed to the 4th equals 16. Okay? I'm going to multiply by 4 on both sides. This becomes x cubed equals 64. Okay. To get rid of the cube, I'm going to cube root both sides. Okay. Cube root of 64 is 4, so this is just x equals 4. Okay, and then I can plug it in and check. Okay, let's do the next one here. So this is log base 4 of x plus log base 4 of x minus 6 equals 2. So what I'm going to do is I'm going to combine these logarithms. Okay. So here, what I notice is that my two logarithms, okay, again, has to have the same base here. Okay, they're being added, so I can use my product property to change them into a single logarithm where I'm going to multiply x times x minus 6 equals 2. Right? I'm just going to keep simplifying it. Okay. So this becomes x squared minus 6x. Okay, and then now, right, we learned how to rewrite this in exponential notation. So I'm going to rewrite this in exponential notation, right? Here's my base, here's my exponent, here's kind of my answer of what we normally think of as answer. So I'm going to rewrite it in exponential notation. So 4 squared equals x squared minus 6x. So 4 squared is 16 equals x squared minus 6x. So now I'm solving a quadratic. Okay, so I'm going to move everything to the same side, so that way I could, in this case, I'm probably going to factor. Okay. So then two things that multiply to be negative 16, but add up to negative 6, that's negative 8 and 2. Okay. Using the product, the zero product property, if two things multiply to be 0, one of those things has to equal 0. So either x minus 8 is 0, or x plus 2 equals 0. So here I get x equals 8 and x equals negative 2. Okay. 8 works because that's positive. 8 minus 6, that's positive as well. However, negative 2 doesn't work because I can't take the logarithm of a negative number. So this is an extra solution. So I only have x equals 8. There you go. Okay. Okay, so why don't you try CYP 5a, and then once you're done, come check your answer. Okay, you should have gotten x equals 9. If you got that right, you can get started on your homework. If not, here is your explanation. Okay, so I'm going to condense them into single logs. So here I can use the power property, so to move it up here as an exponent, so that's why it's log base 7 of x squared. Okay. And then here, because of these two logarithms, same base, right, being added together, I can condense them using my product property with multiplication. Okay. And then I just simplified 27 times 3 is 81. Okay. Then, now that I have a single log on both sides, since the log and the base are the same, I can remove them and just set it as x squared equals 81. Okay. Square root both sides, that gives me positive and negative 9. However, negative 9 won't work because if I plug it in here, that's log base 7 of a negative number. Right? So that's why I only want the positive answer, which is x equals positive 9. And there you go. That's it for today. Have a great rest of the day. Bye, guys.